This video is going to go over questions 1 through 8 on the topic 2 test review. So for question 1, they're asking us to write each polynomial in standard form, then name the polynomial by degree and number of terms, and identify the leading coefficient. So if I look at the polynomial that we're given, we have 4 terms right now. The term with the highest degree is this negative 4n cubed. And so starting in standard form, that's going to be our first term. Then we want to look for the next highest power. So since we're starting with a third power, we're going to go to the second power next. So our next term is going to be plus 6n squared. Then the next term should be linear, so plus 6n. And finally, we have a constant of positive 8, so we're going to write plus 8. So that's our standard form of the polynomial. Then they want us to name it by degree and number of terms. So since the degree is 3, that means that it's cubic. And because it has 4 terms, we're going to call it a polynomial. Sometimes we might need to say that there are 4 terms. And then they want us to identify the leading coefficient. In this case, the leading coefficient is the number -4. For question 2, they want us to write out in standard form the equation of the polynomial that's graphed. So notice that this polynomial is pointing downward. So I know that my leading coefficient is going to be negative. And I know that the degree is going to be even. And so these problems relate to the multiple choice section of the test. So that's one way to kind of look at your function and determine whether the answer is appropriate. In order to find the actual equation like from scratch, what we want to do is identify each of the zeros and their multiplicities. So if I have a 0 at -1, that tells me that a factor of this is x plus 1. Because we have a 0 at 0, that tells us that a factor of this is technically x minus 0. Then we have a 0 at positive 1, so that tells us a factor is x minus 1. And finally, we have a 0 at positive 2, which tells us that a factor is x minus 2. So what we want to do is expand this polynomial, which if I look at this, if this is x minus 0, it's really just distributing an x. So I've got x squared plus x times, if I distribute x minus 1 times x minus 2, I get x squared, and then I get negative 2x minus x, which is going to give me negative 3x. And finally, negative 1 times negative 2 is plus 2. Then we have to distribute out this binomial times this trinomial. So we're going to get x to the 4th minus 3x cubed plus 2x squared. Then if we distribute the x through those terms, we get x cubed minus 3x squared plus 2x. So looking at just the zeros, that gives us x to the 4th minus 2x cubed minus x squared plus 2x. But because of our leading coefficient, we know that it has to be negative. We want to multiply this function by a -1. So that means that f of x is going to be equal to negative x to the 4th plus 2x cubed plus 2x squared minus 2x. So notice there's technically a plus 0. And when we talked about looking at this question as a multiple choice question, that's going to be your y-intercept. So that's another way that you can kind of look and maybe not have to do all of this work to find the correct answer. So looking at your leading coefficient, that we know it's negative because both the arrows are pointing down, and that it's degree again because both arrows are pointing down. And then looking at our y-intercept, so where it's crossing the y-axis might give you the correct answer in the multiple choice question, but since this review is not multiple choice, we would have to do all of this to figure out the equation for f of x. For number 3, we're finding all the zeros of the function and then describing the behavior of the graph at each of those zeros. So when I have 4 terms and I'm asked to find the zeros, that means that I should be able to use grouping to factor the function. So if I look at the first 2 terms, x cubed minus x squared, I can see that they both have a factor of x squared. So I'm going to factor out an x squared. When I do that, that leaves me with an x instead of x cubed and a negative 1 instead of x squared. When I do that with the second group, I should also be left with an x minus 1. Because the first term in this group is negative, that means I'm automatically going to factor out a negative. Since I have x and 1, I'm going to factor out a negative 1. When I do that, I'm really just changing the signs on each term. So the negative x turns into a positive x, and the positive 1 turns into a negative 1. So our groups with the GCF factored out is x squared times x minus 1, and then negative 1 times x minus 1. Remember that the key to grouping is that they have this common factor now. If I can't get the same factor for both, that means that I can't use grouping. So that doesn't mean that I have 2 separate factors. That means that grouping is not an appropriate way to solve the problem. So that gives me x minus 1 times x squared minus 1. Whenever I have a quadratic left over as a factor, I want to determine, can I factor this again? The only way I'm going to be able to factor it again is if it's a difference of 2 squares, which this is. And so I know that the square root of x squared is x, and the square root of 1 is 1. So this is going to factor to x plus 1 times x minus 1. And then I still have the factor of x minus 1 from the beginning. So that means that f of x is actually x minus 1 squared times x plus 1. So since I had 2 factors of x minus 1 here, that's going to turn into x minus 1 squared. So when I'm finding my zeros, this 0 of positive 1 has a multiplicity, of 2. And then this factor of negative 1, this 0 of negative 1 does not have any multiplicity. So remember that when I have an even multiplicity, the graph is touching the x-axis. So the behavior is asking us that what the graph is doing at 1 and at negative 1. So f of x crosses the x-axis at negative 1 and touches the x-axis so when I have a multiplicity of an even number, that's when it's going to touch the x-axis. When I have just a regular 0, where there's no power on the factor, or when that power is odd, because remember that this has an imaginary 1, which is an odd number, we just don't identify a multiplicity of 1. Question 4 is asking us to find the remainder when the polynomials are divided. So what we're going to do is not actually divide the polynomials. We're going to evaluate the polynomial of our dividend at the value that is the 0 of our divisor. So since our divisor is n minus 7, what we're going to do is evaluate the dividend using the 0 of the divisor. So we're going to plug -7 into each place for n in our dividend. So we're going to do -7 to the 4th power plus 7 times 7 to the 3rd power. Oops, 7 times -7 to the 3rd power, minus 6 times -7, minus 52. So if we evaluate -7 to the 4th power, that's going to give us 2,401. Plus, if I evaluate 7 to the 3rd power, sorry, -7 to the 3rd power, that's 7 times -343, plus 6 times 7 gives us 42, minus 52. And so if I think about this, these are actually going to cancel because the 7 to the 4th we know is 2401. So if I'm multiplying 7 to the 3rd with a negative times a positive, this is going to be 2401 minus 2401. And then 42 minus 52 is going to give us -10. And so that means that the remainder is -10. The reason that it's better to use the evaluation method in this case is because, and on the quiz a lot of people miss this, it's missing the x squared term, or sorry, the n squared term. And so if you do synthetic division, your coefficients are 1, 7, 0, -6, -52. And so a lot of people miss this question on the quiz because they didn't add their 0 placeholder. So notice that if we do this with the 0 placeholder, we should get a -10 as our remainder here. So -7 times 1 is -7. 7 plus -7 is 0. 0 times anything is 0. 0 plus 0 is 0. 0 times 7 is still 0. Then we have -6, which multiplied times -7 gives us a positive 42, which also gives us that -10. So again, the reason that this method is better, so it's actually best for you to do both methods so that you check that they match, and if they don't match, go back and try them both again, is that a lot of people miss this, and I saw that on your quizzes. So make sure that you're putting in your 0 placeholders and or also trying the method using the remainder theorem. Okay, so question 5 on this is asking us for the real and complex solutions of the equation. So it's very similar to the one above it, except that we're not talking about simply real solutions. So we aren't saying whether it's crossing the x-axis or touching the x-axis. So we're just finding the zeros. It also uses a different method of factoring. So notice that we have x to the 4th power, x squared, and then a constant. We want to move the other constant over so that we have this equal to 0. So if I subtract 15 from both sides, I get x to the 4th plus 4x squared minus 45 equals 0. So what I want to do is use a product sum chart to determine what my binomial factors are going to be. So I want to multiply a, which is 1, times c, which is -45, and that still gives me a -45. So I want two numbers that multiply to that add to +4. And so the first factors of 45 that I normally think of are 5 times 9. And so notice that if one of them is negative, that will give me a positive 4. So if the 5 is negative, negative 5 times positive 9 is going to give me negative 45. And then negative 5 plus 9 is going to give me positive 4. And so what that means is that I can think about this as x squared minus 5 times x squared plus 9. So when I have this, I want to check, do I have a difference of squares? Can I factor these to find more zeros? So we know that because it's a fourth power, we should end up with 4 zeros. Because we have 2x squareds, because x squared times x squared makes x to the fourth, each of these factors is going to give us 2 zeros. So when we take x squared minus 5 and set it equal to 0, we have to add 5 to both sides, which gives us that x squared equals 5. So if I take the square root of both sides here, that gives me that x equals plus or minus radical 5. So I can't simplify the square root of 5. Make sure that when you do the square root of an x squared, that it has to be positive or negative. So I know that those are 2 of my answers. Then I have to take the x squared plus 9 and set that equal to 0 and solve for x again. So instead of adding, I'm going to subtract 9, which gives me that x squared equals negative 9. For this one, when I take the square root of both sides, I'm not going to be left with a radical because 9 is a perfect square, but I am left with an imaginary number because when I take the square root of negative 9, that gives me 3i. So my 4 solutions are positive radical 5, negative radical 5, positive 3i, and negative 3i. So remember that this power here indicated to me that I should have 4 different answers. Question 6 is asking us whether the function is odd, even, or neither. And so what we have to do to determine if the function is odd or even or neither is evaluate f of negative x. So remember that if it's odd, f of negative x will equal negative f of x. So meaning when I plug in the negative, if the function's odd, it would equal the opposite of everything. So negative x to the 5th plus 2x cubed minus x. So it would change all the signs on each term. If it's if it's even, I was putting even and either together, then f of negative x will actually be the same function. So it won't change the sign of anything. It'll just be equal to f of x. And so it's neither when neither of those things happen. So what we want to do is plug in negative x into each of these. So we're going to do f of negative x and so that's going to be negative x to the 5th minus 2 times negative x cubed plus negative x. And so what we're really thinking about when we do this is the sign going to change or cancel itself out? So remember that when my power is odd on a term, it's going to result in it's going to result in a negative sign. So if I have negative x times itself 5 times, that's going to be negative x to the 5th. If I have negative x cubed, that's also going to change the sign. So the negative is going to come out of the exponent, and so this is going to turn into plus 2x cubed. And then positive times negative x is negative x. And so really what I'm checking is, do the signs on this match the signs here, or do they match the signs here? And so notice that this is actually equal to the negative f of x, which means that this function is an odd function. It would be neither if it didn't match either of them, right? So if the signs matched this, if this was positive, negative, positive, then it would be even if there was something different entirely. So maybe like if this one didn't change, but the rest did, that would make it a neither. So question 7 is asking us how the function differs from the graph of the parent function. So the parent function would just be y equals x to the 4th power. In that case, a is 1, h is 0, and k is 0. So it's centered at the origin, and it's that kind of wide parabola shape, right? And so what I'm looking at here is what is a, what is h, what is k? So for this problem, a is -2. What does a negative do to a function? It points it down. In a verbal description, what we say then is that it reflects it across the x-axis. And then remember that the 2 is a vertical stretch. If it was a compression or a shrink, it would be a number like 1/2. So a proper fraction, a number that's between 0 and 1, creates a vertical compression. This is a vertical stretch because that's a whole number 2. And then notice that there is no parentheses, right? So it's always like x minus h to the 4th. Since there's no number there, that tells us that h is 0. So there is no horizontal translation. However, k is -5. And so that means that it is translated down 5. So that's reflected across the x-axis, a vertical stretch by 2, and translated down 5. Question 8 is having us compare a graph to an equation. And so they're telling us the equation for the volume of a cube. And they're giving us the graph of the volume of a sphere. So this represents the volume of the sphere. So when we're looking at when x equals 3, we're identifying this point. Let's say, so if this is 8, this is 10, so that's about 11. We'll just say that it's 11. So it's going by 2s. It's between 10 and 12, so we're going to say the volume of the sphere is 11. If we're looking at the volume of the cube, we have to use the formula v of 3 equals 3 to the 3rd power. And so 3 to the 3rd power is 27. And so it's asking us which volume is greater. And so our answer is that the volume of the cube is greater. So those 8 questions are the questions that are multiple choice on your exam. So as you're studying, think about how you could maybe eliminate answers and what can make these questions a little easier, and all of that for a multiple choice test.